right, for my Algebra 2B folks, we're going to do a little bit of practice here with transforming the graphs of quadratic functions. I'm going to look at some problems from the packet 9.4. So if you can find this page, 9.4 exercises in your packet, and I'm going to look specifically at 5 through 8. So let's see here. Sorry, I got to get my thing going here. So I'm gonna look down here at this section. So we're going to compare the graph of each function with the graph of f of x equals x squared. So you might remember a couple things here. First, that if the function notation scares you, you can rewrite it as y equals x squared. And whoops, sorry, I'm losing my cursor here. You could rewrite this as y equals x squared, if that makes you feel more comfortable. And that's something we call the parent function. So for number 5, we have g of x equals x squared plus 6, or if you prefer, y equals x squared plus 6. I'll rewrite it that way. And I'll write the parent function y equals x squared. So some of the things we want to consider when we're comparing, three things we want to consider. There is, I'll start with maybe the easiest, and that's the direction of opening. So if you remember, the opening can either be a happy parabola that opens up, or it can be a sad parabola that opens down. And to tell that, it's very simple. We just look at the sign of ax squared plus bx plus c. So let's see here. We've got, or let me back up actually. Let's do that for each of these. Let's identify. So you might be remembering from our parent function that a is 1x squared. And then there are no x's or constant terms. So we can say b is 0, there's no apples, and c is 0, there's no oranges. For our given function, x squared plus 6, we also have 1x squared, so a is also 1. We don't have any x's, so b is 0. And c is the constant term, the number without a variable, so that is 6 here. Okay, so now that we have that, if we talk about how both of these open, we said, okay, so that's looking at the sign of a. They have the same value for a, so they're both going to open up. They're both happy parabolas here. Okay, so that's one thing we're comparing there. Both of these parabolas are going to open up. Another thing to compare would be, let's see, we'll go blue here. Another thing would be the width. We could talk about one parabola being wide, one parabola being narrow relative to each other. But this is also going to be looking at the value for a. So since they have the same value for a, they're going to have the same width. They have the same a value. So that means they're going to have the same width. Okay, one is just as wide as the other. There's not one that's narrower, not one that's wider. They're the same as far as the width goes. And then lastly, if we think about shifting up or down, generally where I would say track the vertex. Is the vertex higher or lower? So a shift or a vertex location. So then this is going to be c. So we have c equals 6 versus c equals 0. So this is going to be the higher vertex. So our function g of x, let me scroll down here a little bit, but g of x is going to be shifted up 6 units. I'll write x squared plus 6. X squared plus 6 is 6 units higher. It would have the higher vertex. Okay. I can box that in. It's been a little while since I've used my pen tablet here, so it's not the best box in the world. All right, so I'm going to jump over to Desmos real quick, and I'm going to graph both of these just to verify that we're saying they both open up, they have the same width, and the one we're given in number 5 is going to be higher. It's going to be shifted 6 units up. So I'm going to come over here to Desmos. I'm already at desmos.com. And so I can type in y equals x squared. There's our parent function. There's our parabola, the easiest parabola you can have. And then x squared plus 6. And I got to scroll down here a little bit, but there you go. So if I were to remove this, or let's do this. If I put in a slider here, I'll put c as a slider. So right now I'm just going to change this. Right now it's at 1. Let me set it to 0. So it matches y equals x squared. This y equals x squared plus c. C is 0. So now this is y equals x squared plus 0, which is y equals x squared. But now as I increase c, what you're going to find out is that that parabola, it's moving up. If I try to get it to 6, there we go. So yeah, that vertex was at 0, 0. Now the vertex is at 0, 6. So we shifted the entire parabola. The whole thing went up. It's hard sometimes to tell here that they have the same width. And that's why I wanted to go back where they lined up. So they've got the same width. And now as we increase c, we're just moving that parabola up. That's all that's happening. Just 6. Oops, oh, there it goes. All right. So I think I'll do maybe one more here. If I go back, let me do, I'll do number 8. Do that one next here. So let me scroll down. Whoops, where am I going? Yeah, get back to my select objects. What's happening? Sorry, I'm having technical difficulties. All right, that's fine. Okay, so here we go with number 8. G of x equals negative 1/4 x squared minus 2. All right, sorry. G of x equals negative 1/4 x squared minus 2. So again, if you want, you can call this y equals. So we've already got, if we compare it to y equals x squared, or f of x equals x squared, we've already said here, for y equals x squared, a is 1, b is 0, and c is 0. If we look at it for number 8, g of x, now we've got a is negative 1/4, b is still 0, there's no plain x's, but c is negative 2. Okay. So 3 things we want to think about again, and I'll start with what is possibly the easiest, and that is the direction of opening. So we know that our parent function y equals x squared opens up, but g of x opens down. Negative value for a, negative attitude, that's a sad parabola. So x squared opens up because its a value is positive, but our negative 1/4 x squared minus 2 opens down because its a value is negative, less than 0. So there's one thing that we can compare. They are not the same direction for their opening. Let's see if on the side I can squeeze in here the rest of it, keep it on the same page. If we look at the width, and this is where we don't care about the sign, but it's the bigger value of a, ignoring negatives, is going to be the narrower parabola. So if we compare, if I leave off the 1/4, we can say our a value of 1 is greater than our a value of 1/4. And again, I know it's negative, but we're ignoring the negative here. So that means this is going to be, if we're looking at a values, this is going to be your narrower parabola. So that means that our negative 1/4 negative 1/4 x squared minus 2 is going to be wider than the parent function. Okay, and then one more thing that we'll check here, and I'll scroll down a little bit, and that would be the position of the vertex. Did we shift up or down? Which function has a higher vertex or a lower vertex? And this is the value for C now. So shift or vertex location. So we're looking at the C values. And so we've got 0 versus -2. So 0 is greater than -2. That means that, let's see here, this is going to be the higher vertex. And this is going to be the lower vertex when we're looking at those values of C. So you might say g of x for number 8, that negative 1/4 x squared minus 2 is going to be lower. It's going to have a lower vertex. You could say it's shifted down 2 units. But let's just fill that in, and then we'll check it out on Desmos. So our negative 1/4 x squared minus 2 is shifted down 2 units. Okay, so that's my answer there. We'll box that in. All right, and then yeah, let's check it out on Desmos. Negative 1/4 x squared minus 2. Let's see if we can get rid of that one. So we'll keep the parent function on there, but we'll do negative 1/4 x squared minus 2. And I gotta scoot this a little bit, but okay. So you might be able to tell that it's wider, the purplish parabola, and it's definitely lower. It's definitely shifted down 2 units there. So I'll do one more thing here, and that's we'll put a slider for A. And then so let's see here, if we put this back, well, let's see. So right now they're the same width. I guess let's change C to 0, just to look at messing with A. So we want to make it a negative. So as you can see, as it's getting smaller, A is now 0.2. The parabola gets wider. Making it negative just flips it. And I can't get exactly, well, on here maybe I can type in, but 1/4 is 0.25. So, but there you go. Yeah, I think you can tell that's wider. So yeah, so there's a few problems practicing with transforming those parabolas. I hope that was good for you.